Initial rates method. So, how to carry out initial rates method. Repeat an experiment several times using different initial concentrations of the reactants. We usually only change one of the concentrations at a time, keeping the rest constant. However, there are examples where we change more than one of the concentrations. Calculate initial rate for each experiment. See how the initial concentrations affect the initial rates, and then figure out the order for each reactant. Once you know the orders, you can work out the rate equation. Measuring the initial reaction rate. For some reactions, there's a sudden color change where a product reaches a certain concentration. In this case, we can use an iodine clock solution, and reaction we're monitoring is H2O2 aqueous plus 2I minus aqueous plus 2H plus aqueous to form 2H2O liquid plus I2 aqueous. A small amount of sodium thiosulfate and starch are added to the reaction mixture. Sodium thiosulfate reacts instantly with iodine being formed. Once all of the sodium thiosulfate has been used up, any more iodine being formed stays in the solution. This is turning the starch indicator blue-black. Varying the concentration of iodide/hydrogen peroxide while keeping everything else constant will give different times for the color change, and therefore we can use that to work out the reaction order. However, for some reactions that produce a precipitate that clouds a solution, we measure the time taken for the mark underneath the reaction vessel to disappear from the view. And for other reactions, we work out the initial reaction rate by measuring the time taken for a small amount of product to be formed.